Hello, class. I'm here to talk about chapter 2. It's quite a few things to cover here. I've been interrupted a few times. So, also, if there are any errors, I'm just gonna keep going. So, please forgive me in advance for any errors. I haven't also done the graphs in Excel in a while, which I do uh, plan. I plan to show you how to graph them, just basic graphs. Um, so if there anything doesn't go as planned, we're just gonna keep going and we're gonna fix it together. So chapter 2 is talk about linear programming. On the first part of statistics, you were exposed to simple linear regression in the line of best fit, which I did show you how to graph and to reach the line of best fit, which simple linear regression is really trying to explain the relationship between two variables, and on the multiple linear regression for more than two variables. We have also learned about the correlation R and the R square, and or the correlation between the two variables, whether if one goes up, the other one goes down, or if one goes down, the other goes up. Is that strong or weak relationship? So far, so on. I actually posted a video in class during week 5 for week 5 about simple linear regression, as since I receive a question in regards to the final cases that are due at the end of the term, and that some questions do relate to trend analysis, regression, R square, and also they do talk about predicted intervals, which would be confidence intervals. So let's go to chapter 2, which think about chapter 2 as optimization. If you're provided a maximization problem or a minimization problem, uh, a maximization problem, you can think about profits or revenues, or like I have put on your discussion this week, fun, maximizing fun, for example. If you're thinking about a minimization problem, you're talking about minimizing your costs or minimizing weight or minimizing inventory space, or there's so many other things that can apply here. The best definition for linear programming, I have actually put it here, which is the best way to think of LP or linear programming. Optimization is the way of life. We all have finite resources and time, and we want to make the most of them, from using your time productively to solving supply chain problems for your company. Everything uses optimization. Linear programming is one of the simplest ways to perform optimization. It helps you solve some very complex optimization problems by making a few simplifying assumptions. And that definitely I find the best definition. Everything in life. So right here I have put you're trying to maximize fun. Okay, think of this equation as your, or this, yeah, the equation that would be correct, as your objective function. So in this case right here, we are trying to maximize this objective function, or we are trying to maximize fun. And then we have the decision variables, which in this case x1, x2, x3, x4. They haven't really determined or explained which one is it. This was just an example that I thought you could pay more attention by maximizing fun. Your constraints and your parameters. What are your constraints? Your constraints, like it says right here, we all have finite resources and time. So in this case over here, we're gonna try to maximize the objective function, what we are trying to maximize, or present to our managers what we're trying to maximize, or if was a minimization, minimize, and then such that, but really your textbook and many other places are gonna say subject to, or you're gonna see the abbreviation S dot T dot, subject to or such that, and here are your constraints. Whatever it is, the pay, it has to be higher or equal than 75, and the time has to be less or equal than 120. So then in this case, 120 hours. Okay, and then everything is no negative or um, xi, which is for each one of this, is higher or equals to zero. So they're integers or they're no negative numbers and they are whole numbers. I have also provided a video over here. However, the video is using Solver, which I am gonna show you how to use Solver as well. But the reason why we're gonna go through all this trouble, should you say, is to really learn how to graph, and once you graph, how to determine which part you're maximizing or minimizing, and lastly, which one is going to be the optimal solution? Which one of this, what values you're going to plug in here, there or plug in this case in here, they're going to maximize your objective function by finding the optimal solution, which is a point on your graph. I have also here listed the steps that you need to follow, which are also mentioned on this video. And another interesting thing that I ask you when you have a few minutes to watch, this one is about a chocolate business, and then this one right here would be a tomato farm business. So please watch them so you can see how things are explained in real life, how this is actually used in real life, and they show you how to graph. And this is what I'm gonna go over one by one.